everyone, it is our distinct pleasure to introduce our esteemed guest, Professor Pedro Domingos, a renowned expert in the field of AI and Professor Emeritus at the University of Washington, where he has made significant contributions to the advancement of AI research. Professor Domingos is a recipient of the prestigious KDD Innovation Award, the SIG KDD Test of Time Award, and has been awarded multiple NSF Career Awards. As a best-selling author, his book, The Master Algorithm, has captivated readers worldwide and helped demystify machine learning for a broader audience. Pedro's passion for teaching and his remarkable ability to communicate complex ideas have not only inspired countless students and professionals in the AI community, but have also earned him the University of Washington's Distinguished Teaching Award. Please join us in extending a warm welcome to the brilliant and engaging Professor Pedro Domingos as he shares his insights and expertise with us today.
All right. Here's what I would like to do. AI is hotter today than it's ever been, and everybody has AI projects either ongoing, deployed, or being started. But unfortunately, too many AI projects still fail. Those don't make the headlines, but they're a reality. And this is a pity because at this point, we actually know many, or at least most of the things it takes to make a successful AI project. And so those failures are often quite avoidable. So what I would like to do is go through a very incomplete set of those things that hopefully will be useful to know, and pitfalls to avoid, some of the art of doing things, the larger contexts, from the picking the project that you're going to do to involving different people within, outside the organization, and so on. So the first reason why many projects fail is that they're the wrong project. And the number one reason why people pick the wrong project, in my experience, is that they have a misunderstanding of what AI is. And that misunderstanding is very natural, or they have, I should say, one of several possible misunderstandings about what AI is. And those misunderstandings, in a way, are very natural, but as I mentioned, they're also easy to avoid. The single biggest misunderstanding comes from the name, artificial intelligence, which is to confuse it with human intelligence, and to think that an AI is just something like a drop-in replacement for a human. You can just replace a human doing something by an AI doing the same thing. And that, unfortunately, is not the case. Artificial intelligence is very different from the humankind. One associated mistake, by the way, which is very much in the news today, is that because of that, AI is going to cause a jobs apocalypse, and you need to be very careful with it, and so on. This is not an idle concern, but for most AI projects, it is not going to do the job of a person. It's simply going to help someone do something. So with some task that can be automated, and that we should choose carefully, as we'll see shortly. Of course, every AI talk needs a Terminator slide. This is mine. Of course, AI is also not the Terminator. We shouldn't, it's not going to overthrow civilization, as some people are saying these days. And there are much bigger things, at least in practical terms, not science fiction terms, to worry about. Another very important misconception about AI that is at the other end of the spectrum, and you've probably heard more than once, particularly as you go high up in a company, you have people who say things like, oh, AI is just applied statistics, so what's the big deal? And the thing is that certainly machine learning uses statistics, but saying it's no more than applied statistics is like saying engineering is no more than applied math, or that a house is no more than a pile of bricks. Statistics certainly provide some very useful bricks for machine learning, but a pile of bricks is not a house, and you still need the architects. Another thing, which again is more common the higher up you go in an organization, is because people see so much hype and so much of it is transparently vacuous, they often think that AI is just a buzzword, and there's really nothing to it, and it's something that somebody's trying to sell you. And there is a lot of hype, but AI is also a 70-year-old field with a lot of very deep scientific contributions. So you have to be wary of the fact that when something is hot, everybody tries to borrow the heat and jump on the bandwagon, and you need to distinguish the hype from reality, but there's certainly a lot of reality that you shouldn't ignore. Another very common preoccupation that the media unfortunately feeds a lot is this notion that AI is a cesspool of bias, and it's going to cause all these unfairness and misinformation and so on. And this is not, again, an idle concern, but a lot of the claims that you see are confusing correlation with causation, something that we, at least in machine learning, should know very well not to do. And in fact, to my knowledge, there has not been a single proven case of bias from AI, of AI that's committed against someone. In fact, people who have studied these things for decades, Danny Kahneman being a famous example, he has a whole chapter in Thinking Fast and Slow about how AIs make much better, much less biased decisions than humans do. So using AI can be actually a fabulous source for combating bias if you use it properly. So those are some of the things that AI is not. What is AI? And I think it's very good to start with this. AI, the technical definition of AI is that it's solving intractable problems using heuristics. Tractable problems don't need AI. Intractable problems, you need to use heuristics to solve. And a heuristic is something that usually works but doesn't always work. And this is something that we have to keep in mind throughout, is that an AI project, including deployment, is that you can't expect the same thing from an AI project that you can expect from a database management system or an operating system or sort of all these classic computer applications. Now, of course, in practice, what these problems are things like learning, vision, language, planning, reasoning, taking actions, and so on, which is of course what human beings are good at. Another upshot of all this, which is very salient these days, I think, is that AI is a moving target. We're always making progress on these things. We'll never be perfect at them. We, meaning, AI scientists, not just humans. Humans are certainly not perfect at them either. And you got to plan for that. If you start your project with today's AI in mind, by the time it's deployed, it'll be outdated. So you have to start your project with what's coming next in mind, and I'll hopefully have time to say a little bit more about that at the end. One very good way I've found of thinking about AI relative to the existing organizations is that it's a force multiplier. Where you might have 1,000 employees, with AI, you effectively have 1 million if you do things right. The flip side of this, which is very ironic, is that AI and machine learning in particular are actually very labor-intensive activities. It takes a lot of human effort to get a machine learning system to work properly. A lot of things you have to try, a lot of things you have to fix, and so on. But the bottom line is the return on that labor is often extremely high, and that's the #1 reason AI has become so popular. So let me go through a little bit of background, which for many of you may be superfluous, but is useful to have before getting onto some of the meat. There's a jungle of AI systems out there, a lot of different machine learning algorithms, more every day. In order to not lose yourself in the jungle, it's useful to keep in mind that essentially all these algorithms are made of 3 key elements, and knowing them, I think, is very good for not getting lost. The first element is representation. It's the choice of language that you use for the AI to reason in. For humans, there's things like English and Chinese. In ordinary computer science, there's things like Python and Java. In AI, it's things like deep networks, knowledge system, knowledge bases, graphical models, and so on. The evaluation and representation is really a scientific question. This is where a lot of the science goes. Evaluation is where a lot of the business goes. It's choosing the metric that your system is going to optimize. For example, in social media, famously or notoriously, it's engagement. It could be click-through rate. It could be something as abstract as return on investment. It could be something as concrete as minimizing the squared loss or the number of errors of your system. But this is definitely something that should be very carefully chosen. And finally, there's optimization, which is where a lot of engineering goes, which is what is the algorithm by which your AI maximizes that measure that it's trying to maximize. And a classic example of that is, of course, gradient descent, which is what deep learning uses. And now the key difference between machine learning and traditional programming is that in traditional programming, the data and the algorithm going to the computer and you get an output. In machine learning, what goes in is the data and the output that you would like to be produced from that data. And the system produces the algorithm that turns one into the other. So you might give it, for example, x-rays of lungs and diagnosis of lung cancer, and the system learns to produce a diagnosis of lung cancer. Obviously, a very powerful thing if you can do it. Now, there's a number of major different AI paradigms, and it's good to be aware of all of them, not just the hottest one or ones, which these days is deep learning. The 5 major ones are deep learning, symbolic AI, Bayesian inference, evolutionary computation, and reasoning by analogy. And many of you, of course, know that I've written a whole book about this, introducing it to people with not necessarily a technical background. So you can learn more about them there. So now, let's say you've decided to go ahead and do some AI. What the question that you want to ask before you get going, and now sort of like becoming somewhat more specific, is what kinds of tasks, generally speaking, is AI good for? Projects often fail because people were trying to use AI for something that it wasn't very good at. And often many opportunities go unexploited because AI was good for something that it was not used for. And here's a general heuristic, again, not without exceptions, but AI is good for tasks that are narrow and well-defined, and you have a lot of data to learn from, okay? Now you could ask, isn't ChatGPT broad AI? That's an interesting case. In some ways it's broad, but in some ways because it's learning from very broad data. But in other ways, it's actually still very much a narrow and brittle AI application, as its hallucinations and failure modes show. So AI will get broader as we go, and we're seeing that. But I think as a starting point, this is still a very good one. Another very important thing that people often forget is that because AIs will make mistakes, they are best for tasks where the cost of errors is low. So ad targeting, spam filtering, great applications for AI. Self-driving cars, maybe not just yet. Another one, less obvious but very important one, is AI is very good for tasks we don't know how to program. We know how to walk, but we don't know how to tell a computer how to walk, but it can learn from data. And another one, even less obvious one, perhaps, is tasks where humans don't scale. There are many things where we actually do know how to explain to a computer how to do it, but the problem is that it's infeasible to do it with humans. So think of a recommender system, right? The Amazon recommender system is like having a shopkeeper that knows every product on earth and knows you very well. You could write down a lot of that stuff, but it's of course much better more feasible to learn it from data. So on the flip side, there are things that AI is not good for. And you should, be aware of those. There is one big one which has been the case since the beginning and still is, unfortunately, which is common sense reasoning, right? AI has no common sense. Even ChatGPT is still, sometimes it gets things right, sometimes, it falls completely flat, precisely because it has no common sense. So you as a rule don't want things that require a lot of common sense knowledge, often knowledge that you're not even explicitly aware of. Another thing it's not good for is integrating a lot of disparate information. And this will improve as time goes by. It's already a lot better now than it was 10 or 20 years ago. But you're a priori, at least in the beginning, you're much better off starting with something that you can fairly well delimit the information that is required to do it. Another one is flexibility. AIs are notoriously brittle, and machine learning makes them a lot less brittle, but the brittleness is still there. And another one is maybe the least intuitive, but in some ways the most striking one is AI is good at the opposite in some ways of what humans are good at. AI is very bad these days at still at things that require sensory motor coordination. Things like robot control and so on are actually very difficult for AI, where things like generating text are not so difficult, at least at some level. And related to this, there is this fact that people get blindsided by over and over again, is that we tend to think of certain things as being easy for AI because of the image that we have of a computer or of what we think about intelligence, and others as being hard, and quite often it turns out to be precisely the opposite. So for example, people in the early days and many people today still have this impression that white collar work is hard to automate and blue collar work is easy, and in fact it's the opposite. The construction worker is hard to automate, the doctor and the lawyer less so. If something requires a college degree, it's probably a good candidate for AI, paradoxically, or not. Emotion, many people think is hard to automate, but actually it's quite easy. There are successful bots that do that, and it doesn't even take AI. Cognition is hard. Creativity, people used to think was very hard. These days, of course, we know from the news and from playing with DALL-E and Midjourney and ChatGPT that actually not so. Reliability, doing a task even such as calendaring reliably is actually quite difficult. Wine tasting seems like something for wine experts. The figuring out what is the vintage of a wine, very easy thing for machine learning to do. We've done it well for 20 years or more. Housework, doing the dishes and making the beds, that's hard. Selecting players for a sports team like baseball, as Mike Lewis showed in his Moneyball bestseller, we can do that, even though you wouldn't think so. Construction work, as I mentioned, is quite hard. And as a general rule, anything that requires expert knowledge is potentially a good candidate for AI. Everyday tasks seem trivial, but they're often very hard. And one upshot of all this is that you don't know until you've tried. You really don't know if AI is going to be good for something or not until you just try it. So you should just try it if you can do it, with a small amount of time and cost. There is, however, one, I think, large pattern that is worth remembering, and this is the following: is that we in school learn what you might call strong knowledge. Like, think of knowledge as a pyramid with math at the top, comparatively small amount of very strong knowledge. And then physics, there's more knowledge, it's not quite as rigorous. And then biology and other sciences, more and more knowledge, less rigorous. But even all of this is still only a fraction of all the knowledge you need to successfully run an organization. Most of the knowledge you need is very specific. It's this process, that routine, that product, that customer, that relationship. And the good thing about a lot of this knowledge is that these days it's there in the data, and machine learning can actually extract a large chunk of it. And doing a lot of those small things is often what machine learning is best for, as opposed to doing a few big things, which is often what you associate with the word knowledge. So here's another, moving on to sort of like the next stage, where you're considering maybe some demos in the domain that you are interested in. And AI is very good at producing flashy demos. In fact, too good. It's too easy to get machine learning to do something that looks really well when you see the demo. There are many examples that you can probably think of. I need not go into. But the problem is that we humans have an enormous tendency to project ourselves into anything that seems to act intelligently, and in particular to project a lot more intelligence than really is there. So you shouldn't believe an AI solution until you've tried it on your problem and varied the problem and pushed back in a number of ways. And if that works, then you should start to be more convinced. Here's what I think is a very nice, simple example that illustrates this point. And again, this type of example occurs over and over again. So some colleagues of mine at UW did this. They trained a deep network to distinguish between dogs and wolves. And it worked pretty well, as you can see some examples here. But then they investigated what it was actually learning. So if you look at these images for a second, look at what it gets right and what it gets wrong. Can you see what it is that the network is really doing? What it's doing is detecting snow in the background. It actually doesn't know anything about dogs and wolves, but it detects large white patches, which maybe for some things is good enough, but definitely shouldn't confuse it with understanding what the difference between dogs and wolves is. So now you are in the middle of your project, you've picked something to do, you've started doing it. Here's a few things to remember. Number one, data is not the new oil, data is the new soil. Soil needs fertilizers, soil needs to be kept in good condition. The care and feeding of data, data quality, data integration are extremely important. You really need to have people whose job is to take care of the data, and taking care of the data will probably be a large fraction of the project, more than the modeling, maybe 90%. So you should be aware of that. The next one is beware of the man with the hammer. Many people have one tool or one paradigm of the 5 that I mentioned before that they've learned, and they just want to use that. So don't fall into that trap. Deep learning is very sexy. Maybe you should try nearest neighbor first, or logistic regression, because they're much easier to get to work and they might actually get you most of the way there. So be aware of that. And one thing that you should always try to do when talking to someone who's proposing a solution, a particular type of model or whatever, is what are the assumptions that this makes? If the assumptions are implicit, you should make them explicit. And then you can figure out whether it makes sense at the level of those assumptions. So for example, different types of learning algorithms do make different assumptions about what's going on that they're going to rely on. And then once you've done that, it is the case that typically the first solution, the quickest solution, will be largely an off-the-shelf algorithm that you tweak in various ways. But in the long term, the best solution is almost always a one-of-a-kind solution that you've developed, often at great cost for your problem. Think of the Google ranking function or the Amazon demand forecasting system. These are the crown jewels of the company. And they're, at the end of the day, they are machine learning algorithms that are different from anything that went before. So this is the path that you should, probably be on, is from the first quick solution to the best one for your problem that will be a huge asset to your organization. So the next step is, well, how is this AI going to play with what the humans are already doing in my organization? This is often a very salient issue for a number of reasons. And the key thing to realize is that, look at the simple Venn diagram, right? There's what AI can do and what humans can do. Their intersection is actually quite small, but it's what everybody's always thinking about for good and bad reasons. And really what we're interested in most of the time is the part that AI can do that humans can't, because it's a no-brainer to go for that. And then to figure out what is the best way to combine the humans and the AIs, which actually gets us, before that, what AI can do tomorrow will be more than it can do today. So you have to keep that in mind. So that intersection will increase. But again, the part of AI outside intersection will increase even more. And that's what you want to be on the lookout for. But the biggest point in all of this is that the bigger part of this diagram is what humans and the AI together can do that they couldn't do individually. It's not the AI by itself, it's not the human by itself, it's not man with machine, it's not man versus machine, it's man with machine versus man without. And the human and the AI doing something well together actually often involves a lot of the humans figuring out what is the best way to work with the AI. So that is a very important component of this. It's not just produce the AI system, it's that people need to know how to learn how to use it. And in the future, the AI will be learning the people as well, but so far that part is mostly on the shoulders of us, the humans. So you have your wonderful AI solution, and now what happens, unfortunately, most of the time is that it worked, but it doesn't get deployed. And why doesn't it get deployed? Often because the experts in the organization, there are many barriers, but a salient one, and one of the first ones to hit you, if you will, is the experts in the organization that actually don't like the AI. And there's this cycle that I've seen over and over again, and you should be aware of, which is the first stage is that the experts pan and ignore the AI. They're like, oh, we're the pros. We know how to do this. How could AI possibly do that? What a joke. AI is terrible. And then, of course, when AI makes mistakes, as it always does, this seems evidence that the AI is no good. And often things die right there. But then what happens is you get more data, you get better at the machine learning, you get better algorithms, and at some point, in one domain after another, the AI leaves the experts in the dust. At which point the data scientists are like, "See, I told you so," and then the AI gets deployed often to very great effect. But the story doesn't end there. At some point, the data scientists run out of things to try, but there's still a demand for better performance. And at that point, often the experts go and the data scientists go and rediscover the experts that they'd forgotten about, because as it turns out, they did know some things that were kind of like superseded by the AI, but often, in fact, almost always, they knew some things that weren't. And usually the best AI at the end of the day is one that incorporates both very good machine learning, but also a lot of very non-obvious domain knowledge. So, you know, in your project or organization, you might be at one of or another of these stages, but it's good to be aware of all of them as you go through the process. The next thing to be aware of, which a lot of organizations unfortunately forget, is that for an AI project to succeed and for the organization to make most of the AI, it's not enough for it to be something that the data scientists do and that's it. Think, for example, if in an organization, the only people using word processors and spreadsheets were in the IT department, because it's IT, right? So why should anybody else deal with it? Well, that would be a big mistake, obviously. But that still happens a lot these days with AI. It's like AI is somebody's job. And it certainly is somebody's job, but in additionally, it is everybody's job. And what you want to do is you want to get the AI into everybody's hands, which takes different things for different kinds of people. And you need to have all of those in mind. And this runs the full spectrum from your customer, a lay person who just wants to use the results with as little hassle and as little knowledge as possible, all the way to the expensive machine learning PhDs that you will probably have to hire. But that also includes, and of course, what these people need is very different. And in between those, there's also, for example, the casual user within the organization. This is someone who is probably going to spend a lot of their time playing with the AI or the model or the results of the model, and needs to understand it at a certain level, not at the level of what the algorithms do, but at the level of what the results mean, of how do you make it get to do what you want. And then there's the professional user, which is, for example, you know, your expert that is very good at something, and maybe in the beginning is grudgingly you know, learning as little AI as possible, but what you want is for them to be able to relate AI to their expertise. This is actually one of the most important things. It's not just here's this AI and forget what you know how to do. It's like, how do you get the AI to combine with what you know better than anybody else? And for a lot of organizations, this is actually where their key advantage in using AI is, compared to, say, you know, one of the big tech companies that have a lot of AI and very advanced, is that like they have people who know the domain better than anybody else. And if you can combine that with AI, and often the combination is subtle, that's a big advantage. Then there's people who manage the data scientists, which, you know, I'm guessing many of you probably are. You need to know data science and AI now more than just a professional user, because you're going to be interacting with the data scientists a lot. This still doesn't mean that you need to know things at the, you know, nitty-gritty level of the mechanics of the algorithms and whatnot, but you need to be able to know at the level of pushing back on somebody says, I'm going to do A, and you go, well, but you know, A has these issues, has these shortcomings, and for this project, this is very important, and what about B? So that type of dialogue is very important. You can't have it unless you have a knowledge of AI, for example, at the level of the master algorithm, the book that I mentioned before. Then there's, of course, the data scientist, who at the end of the day is the crux of all of this. These are the people who are going to be working with the algorithms all day. And this shades all the way to the people with PhDs in machine learning. Some people with PhDs in machine learning are, you know, indistinguishable from data scientists in terms of what they do. There's also, of course, a lot of data scientists who don't have and don't need PhDs in machine learning. At the you know, at the far, you know, end of the spectrum, there is the person who, what they really do is not use or tweak existing algorithms, is to come up with essentially new ones. And this is something that often you don't need, at least in the beginning, as I mentioned, but in the end, to get the best results, you probably do need that. And for that, you do need to hire those expensive machine learning PhDs, but as I mentioned, it's often quite worth the return on investment. And you can interest them. You know, they're also, you know, hard to find often because the demand so far exceeds the supply, but you can entice them to your organization and your project in two ways at least. One is by showing what interesting machine learning problems there are, things where just something out of the box wouldn't work, but also with the impact that they could have in your area, which is often some machine learning research are motivated by love of the tools, if you will, but often they're motivated by having a large impact in one area or another, and that's, I think, an opportunity to get them interested. So now you have AI in your organization, you're using it, and now here's a question that I see coming up all the time: is should you have a centralized AI group or a more decentralized one? And often what happens is that different units of the organization, whether by sector or by area or in many different ways, they start their own AI projects, which is good, but then there's a lot of duplication, and you create a central AI group, and that's good because it solves that problem. But then often the business units and the central AI team feel that the other one is not very responsive. So what is the solution to this? I think that usually at some point the solution becomes, for most organizations, to have both and to have motion between them. You have a central group that works on problems that are common to the whole organization. There's also connection to the AI community to bring in stuff and share problems that are worth sharing. And then you need people who maybe started in a specific area, but then what they're doing is more general. They go to the central AI group, or people who start out working on a general machine learning problem, and then there's an application in some area, and they migrate to the area. So you want to keep this dynamic flowing, and this, I think, is very important for the health of AI in the organization. And just to mention more broadly, there's the whole AI ecosystem, right? There are thousands of companies doing different kinds of parts of this project, of this process. You may have seen this famous chart that Siobhan and Zilis and Matt Turk produced, and every year it doubles in size and gets more incomplete. But the bottom line is, it's worth getting to know every part of this ecosystem that because you might need it. It's also, very worth coming to conferences like this one to learn, these things and keep up on what's coming. So here's one question, which actually I will skip over because time is getting short. This is how to deal with the tech giants. I will also skip over this one because we're short of time. This is just a mention of the few things that are coming out of the labs, so that you want to be aware of them. These are not what's out there today, or in some cases, depending on the area and the company, it's starting to be. But again, you do want to be aware of these things, and this is a very, of course, incomplete list of some of them. Let me just conclude with the following. What does an AI-powered company look like? And here's three brief metaphors that hopefully will make you think. One is that, an AI is like a brain, but not like a human brain. The human brain is too centralized to be a good metaphor for AI in an organization. Maybe a better metaphor is an octopus, right? Octopuses are not very popular, but they're one of the most intelligent creatures on Earth. And the thing about them that's very interesting is that they have a different brain in every arm. And then they all work with each other and with the central brain, which is quite fascinating, and I think is a lot more like how AI in an organization has to be. Another one is that another metaphor is that AI is a little bit like flying a plane. In an AI-powered organization, and we already see some of those, for example, in the tech sector, most of the everyday work is done by the AI, and should be, because it's done more efficiently, better that way, and so on. The job of the people is to steer the ship, if you will, is to control at a high level these processes that under the hood turn into a lot of computation. But you shouldn't have the people trying to do those things under the hood that are better done by the AI. And finally, I think the big promise of AI is to make the intelligence of the organization be more than the sum of the parts. It's hard to make a large organization work. It's amazing in some ways that you can make them work at all, given our brains that are Paleolithic old. And often the intelligence of the organization turns out being less than the sum of the intelligence of the people in it. And it's not the people's fault. It's the rigidity of the organization that prevents it from being more intelligent. But with AI, so information technology in general already made a big difference to that. But I think with AI, we really have the potential to make an organization that is a lot more, whose intelligence is a lot more than the sum of its parts. And we're seeing that becoming real at a very fast clip today. So this is an exciting time to be alive. So good luck with your AI projects, and I'll take questions now.
Where it mentions, could you clarify what you mean by AI bias?
Oh, so I'm glad you asked that question, because the word bias in AI, unfortunately, is used in 4 very different ways, and it's good to not confuse them. So the first notion of bias is the statistical notion of bias, is this famous decomposition of errors that a model makes into variance errors and bias errors. Bias errors often come from the fact that your model is not powerful enough, so it gets certain things systematically wrong. Variance errors come from the fact that it's too powerful and it kind of like overfits the data. And tuning that dial is very important, and every learning algorithm has one or more buttons to turn that. Then there's machine learning bias, or inductive bias as it's often called, which is really a very good and important part of machine learning. This is the set of preferences for the knowledge to learn that the system has a priority. Because there's this thing called the no free lunch theorem that says without such biases you can't learn anything. So you have to put in those assumptions whether you like it or not, and being aware of them and making the right ones is actually a lot of what the job is about. Then there are cognitive biases, which is what Danny Kahneman is world famous for exploring. All the cognitive limitations that we have that cause us to go wrong. And these cognitive biases are the flip side of the heuristics, right? When a new heuristic fails, it's called the bias. Availability bias. I mean, there's all these different biases. And then finally, there's what you probably most often see called biases in the media when talking to AI, which is the more everyday sociological notion of bias, which is, race biases, gender biases, and whatnot. And you see a lot of talk about AI having biases, and it can have them, in particular data can have them. But often people mix up these biases with the other ones, or as I said, they confuse correlation with causation. So it's very important to keep all these things straight.